Hello everyone, welcome to Reactify Labs. Today I'm going to talk about visitor design pattern. It is a behavioral design pattern, and if we go by technical definition, it goes like this. Visitor design pattern is a behavioral design pattern that lets us separate algorithms from the objects on which they operate. Okay, so the objects and algorithms are separate. But if I have to explain it to you in simple terms, I'll do it like this. But before that, let me write visitor here. Mm, Visitor, do I write pattern? Yes. Okay. So, in simple terms, how we are going to explain is, let's say you are making a video game. Okay. And in that game, you decide to use some animals. Okay. Since you are the only engineer of the team which is making this video game, you decided that you will just make a MVP, minimum viable product, which will just do the job. It will be a bare minimum game. Okay, it will be just say like Talking Tom. Okay, so what Talking Tom does is it has a cat. mm, I hope this is a cat. Yeah, I know I'm a good drawer, so artist. So please don't start clapping for me. Let's say this is a cat. Okay. Similarly, there can be a dog or whatever. Okay. So your game goes like this. As people open your game, they are asked to select their animal of choice. Okay. Select animal of choice. Once they select an animal, they can press a button. So there is a button there, they can press it and it will make a sound. Okay, if the animal is a cat, it will make cat sound, meow, or if it's a dog, it will bark. Okay, so this is the game you decided to make. Then it's fine, you can do it, right? Uh, so how can you do it? First, let me tell you what's happening here, and then I'll tell you what's the problem, and then you will understand. Okay. So we are going to use an animal interface of animal. And what it does is it will just make sound. This is the only function it will contain. So whoever extends it, for example, let's say class dog extends it. Okay. I think it will be like this. Class dog extends animal interface. So obviously it has to implement its own make sound. It will override that. I can add override here, but I'll not do it. Okay. And let's say the make sound functionality of dog, what it does is it will print, we are printing woof. Okay. And that's it. There will be another animal called cat, class cat, and again it will override this make sound of the interface, and it will print meow. Okay, so that's it. Your game is live now. You have given the functionality where people can select an animal, and whatever sound they want, they can make them speak. Okay, let's say your game started becoming popular and you started taking more interest on it. A project which you just started as a hobby or as a side project just to improve your skills is now gaining traction, and now it is possible that you may start earning some money. So what you can do is you have decided that you will add more animals. Maybe you decided to add a rat, maybe you decided to add an elephant, maybe you decided to add a tiger, a lot of things. But let's say, like this, you have added 1,000 animals, 1 million animals. Okay. All the animals in the world, like a dog, cat, aquatic animals, even the microorganisms. uh, if that's not enough, you might have started assuming what kind of sound plants will make, and you started doing that as well. But there is a limit to it. You cannot uh, extend the functionalities beyond adding number of animals. Okay. It's just a hypothesis. So uh, it's 1 million is a lot. Let's say you added already 1,000 animals. People don't even go for 1,000 animals. Let's say it's 100 animals or 1,000. Okay, that's fine. So now what happens? People got bored of your game, because this is the world in which you have to keep evolving. If you don't give them something new, your product will die. The people will get bored of the game, or somebody will copy your idea and they will make a better product. Okay. So to tackle this, you decided to improve the functionality. So instead of just making sound, you decided that why not I give another functionality called, let's say, fight. You wanted to add a fight to every animal. Okay. Now what happens? If you want to add a fight, what you need to do is you need to first change your interface. You have to add a fight in the interface of the animal, and then you have to add a fight on all the animals. Let's say if you have 1,000 animals, 1,000 classes for the animals. For all the 1,000 classes, you have to add this fight function. Okay, you may think that, okay, this is a one time thing, you can do that, you will extend the class. Later, let's say they decide to dance, because obviously people will get saturated of your game, so you need to keep evolving. So now you have dance, then you again have to make changes to all the 1,000 classes for dance. Let's say there is one more thing like stand. Again, for all the 1,000 classes, you need to make a change. There is two fundamental flaw here. First is, we have, for every one change, we have to go and change all the classes. Okay. And second is, we are violating the solid principle. The O, which says, which is open close principle. It says like, anything, this class should be open for extension but closed for modification. It means you should not make any changes to already made class. Okay, then what can we do? This is the problem that visitor pattern solves. I hope the problem statement is clear now, why we need visitor pattern. Now let's come to the solution. Okay, let's see the solution. Okay, again, we will have an interface animal. Okay. Interface, and sorry, so it will have a functionality called make sound. Okay. And we don't know yet if we are going to extend our game, because like, assume you are again starting the project from the beginning. But it is possible that you might extend it, so it's better that we will add another function called accept. If we use it, good. If we not use it, then nothing. Nothing is getting wasted here. Okay. So that's what we will do. Okay. And after that, when we started using by the way, this accept will take something as the parameter, so I'll talk about that later. And we have a class dog, which will extend it. Class dog, not extend, it will implement it, because it's an interface. I'm not writing interface class dog implements animal, so just assume it's there. Okay, this class is extending this or implementing this. It has a make sound. What this does is, it prints woof. Okay. Good. We are good here. Now we have to override accept as well. Okay. Accept will do something. It will take something and it will do something. Okay. Hmm. Now the question is, what will accept do? Similarly, there will be a cat which will also have the same thing, make sound and print woof, print meow and accept. What will it accept? So here comes the visitor. What we are going to do is, we are going to make another interface called, here we have animal, so animal visitor. Somebody who will visit the animal. Okay. And it will have something. For now, by the way, it will have a visit function here as well. There will be two for, because right now we have two animals. As we have dog, similarly we have a class cat. Okay. So right now it will have two things: visit of an object of dog and an object of cat. I'm sorry, cat space cat. Okay. So if we have dog and cat here, we know that it has something to do with these dog and cat classes. Okay. Now, let's say we want to make the animals fight now. Okay. Before that, yes, this accept, what will this accept? This will accept animal visitor object. Animal visitor, let's say AV. And this will also accept this dog. Dog will accept what? Similarly, as above, animal visitor AV. Okay. Now, how this works is, we have to add another functionality. We got to know that we have to add another functionality, which is fighting. So let's say we have a fight visitor class fight visitor. Now we know that we have to override these visit dog and visit cat, right? So what we are going to do is, we will override this visit of dog, and we will print something like print, let's say dogs fight instance is ABC. Okay. And for cat, again it is visit cat, its fight instance is print XYZ. Okay. Now we know that this visitor has all the instances, five instances of all the animals. Now what we are going to do is, we need to make these animals fight. Okay. If you see this, what is it accepting? The dog is accepting animal visitor. So if we make this dog accept fight visitor, the dog will start fighting, right? So how we are going to do it is, let's say our client is here, which is going to use it, client code. Okay. What it will do is, it will create a new instance of the animal. Let's say animal dog equal to new dog. Correct. And then if we have to make a sound of the dog, it will just do dog dot make sound. Right. It will just do dog dot make sound and it will make sound. But now I want to make dog fight. So what I will do is, I will create another object, animal visitor fight, which will be new fight visitor, right? I will create an object of the fight visitor, and what we'll do is, we have a dog, we have to make the dog fight. So the dog will just do what? Dog dot accept, and it will take the fight as the parameter here. Now if you see what happens, when dog dot accept fight is called, then dog dot accept, okay, fight. What fighting does is, if you see, I have not defined this accept. Okay. So what this does is, this will call this, we have AV dot, this will call the visit, right? This will call the visit function, which it's there with this. This means it's currently inside the dog object. So with this dog object, it will call the visit. So basically what happens is dog.visit got called, dog.accept got called, which in turn calls av.visit. What is av here? Av here is fight. Fight.visit gets called, and this fight.visit calls which visit will it call? With this. We know that this is inside dog, so it will call the visit with the dog object, and this dog will be it will print abc. So when dog will accept that okay it has to fight, when we have to make the dog fight, we all need to do is we'll call the dog.accept with fight. Let's say tomorrow we have to make a new thing, like we have to make it dance, make the dog dance. Then what will we do? Again, we will extend this, right? We will extend this interface with a class called dance visitor. Okay, this dance visitor will again visit dog and cat, and again here we will have another similar thing like animal visitor dance equal to new dance visitor, and then this dog will accept dance. So what will happen when dog will accept dance? It will go and call here. This dance dot visit will be called. This dance will have its own visit with this pointer. This will call, not pointer, sorry, pointer is for C and C++. This object, and this object will call with the dog. The dance of the dog will be called here. There will be a dance functionality of dog. There will be a dance of cat. This dance of dog will be called, and the dog will start dancing, and your game is going to be good, right? Okay, I know one question might arise: what happens if we have to add more animals? For example, let's say if I decide to add rat or an elephant tomorrow, what will happen? See, there are two approaches for this. Either we have to extend this visit, we have to modify this interface and this class. First thing that is we can do. Second thing is we will explore later the other design patterns which may help us do that. So in the first approach, you might ask, we are still going to modify the existing class, we are still going to violate the solid principle, open closed principle. So how is this good? This is good because if you see, our game is only this one, right? This is the portion where our game is. This is a separate code. Here we can make our modifications and it will not break our actual game. So we are allowed to do this. Okay. And this makes our code cleaner. This separates the creation logic, assigning responsibilities logic from this actual game. So this is what visitor pattern helps us achieve. And I hope this helped the viewers clear the visitor design pattern concept. If there are any questions, please let me know in the comments. And thank you for watching. Please remember to like, share, and subscribe. I'll see you in the next one.